Hi, Assalamu alaikum, dear students. How are you? Today we are going to introduce you very interesting numerical, which is related to the heat. What is that numerical? Uh, when boiling a pot of water, some of energy is used to increase the temperature of water, while some of energy is required to convert liquid water into the water vapors. From total energy required to convert 100 ml of liquid water at 25 Celsius to water vapors at 100 Celsius, calculate what percentage is used to increase the temperature of the water. If we simplify this numerical, uh, what is the purpose of this numerical? Basically, we wanted to calculate the percentage of the heat which is required to increase the temperature of the water. Basically, in this statement, heat is divided in two parts. One part of the heat which is provided to the 100 ml of the liquid water would increase the temperature from 25 Celsius to the 100 Celsius. One part of the heat uh, which is only used to increase the temperatures. Second part of this heat which is used basically to change the phase of liquid water into the vapors, or in gaseous phase you can also gas. Basically, it's mean we need to calculate two types of energies. First of energy which is related to increase the temperatures. Second one which is used to change the phase of the liquid water into the vapors. Standard enthalpy is given, that is the 2257 joule per gram. Specific heat of water is we know already, that is a well known value, 4.184 joule per gram Kelvin. Now we are going to the solution, how we solve this problem. Basically, we need to calculate the percentage. How we calculate the percentage? Basically, we are going first of all its final formula. Basically, if percentage is calculated, energy is used for heating or increase the temperatures divided by the total energy and multiply with the 100. Now we stepwise we solve this numerical. First of all, we calculate the mass of water of 100 ml. Basically, we know that the density of water is around about 1 gram per ml. So all the liquids which have a density is equal to 1, there is the volumes and mass around about equal. It's mean water 100 ml will be equal to the 100 gram. Okay. Now we next step we calculate the energy or heat, in the other word, sensible heat, which is used to increase the temperatures. The formula of this calculation is Q is equal to mc del T. M is the mass of the liquids, C is the specific heat, del A del T is the change in temperature from 25 to 100 Celsius. Basically, 100 gram is the mass of the liquid water. Basically, that's the specific heat of water is 4.18 joule per gram, and change in temperatures, final temperature is 100 and initial temperature is 25. It's 100 minus 25 is 75 Celsius, which change into Kelvin. Basically, that is also is the 75 Kelvins will be equal to the, consider that is equal to 75 Kelvin. Basically, you can use this temperature as such, 75 Celsius you can use. Okay. Q 100 multiplied by 4.18 multiplied by 17 our sensible heat, which is used to increase the temperature from 25 to 100 Celsius, is 31,380 joule. That's the one part of the numerical is solved. Next part, we uh, calculate the energy which is used to change the phase of the liquid water into the vapor phase. How we can calculate? We know that delta H, that's the enthalpy change, is given, and we multiply this delta H with the mass of the liquid. Mass of liquid understood is the 100 gram, and delta H is given in the statement, that is the 2257, multiply with the 100, 22,005 700 joule is the energy used to change the phase of the liquid water into the vapor phase. Okay, now we sum up the both types of energy, and we calculate the total energy, the total heat, that is basically 53,9 and 500 joule, basically 5,39,500 joule. And now, very easy how to calculate the percentage of the energy used for heating. In other words, that is basically percentage of the energy which is used to increase the temperature from 25 to 100 Celsius. The energy which is used to increase the temperature, divide by total energy and multiply by the hundreds. Answer is 12.2%. I think you understand this numerical, very easy and very interesting numerical. Next numericals in the next video. Take care. Bye bye.